Same notes. Let's do a recap. Last session when I taught you chapter 14. Chapter 14 was called binomial distribution. You had learnt binomial distribution, which you can say x is binomially distributed. So that little asterisk or the little squiggly line means distributed. Begin. Okay, so binomially and NP. So N is the number of trials, P is the number of success. Now let's do a bit of a recap. How do you know it's a chapter 14 problem? What are some things you have to look for? Name me one. How do you know it's binomial? What do you have to look for? Two outcomes. It needs two outcomes, hence binomial. You need two outcomes. What else do you need?
Number of trials.
What about the number of trials?
It needs to be a number of trials, right?
Yes, there is a number of trials, but something about the trials is important for it to be a binomial problem as well. What about the trials? Three conditions in total. So it needs to have two outcomes. The trials must be independent. Each trial needs to be independent of each other. Okay, so it needs to be independent. And then the last one, which is the key part, that's why you can use binomial distribution. All the probabilities must be. What about the probabilities? Every trial, so every flip, every roll that you do has only two outcomes. You either get it or you don't. Okay, and each one is independent of each other, but also the probability of each event is
Equal.
very good. It's equal or constant. It has to be the same. So essentially, if I flip a coin, and because it's independent, remember, if I flip a coin 10 times and I got all heads, right? It shouldn't affect my 11th one. You shouldn't be saying, oh, your 11th one's definitely tails. Like, we don't know. It's still 50-50 because they're independent, but the chances of each one is also the same. Yeah, so it's a great example of replacement problems. So anything that is a replacement, with replacement, probabilities are constant. Okay, so probability must be constant. That's how you know it's binomial. So those three things must occur. That's called a Bernoulli sequence. Okay, so you have to have a Bernoulli sequence for you to identify it's binomial. And then, yes, we have number of trials and the probability is always constant. Probability of success. Okay, so you've got success versus failure. Let's test your memory again. Your general binomial distribution formula, so probability of your random variable, x, capital X equals little x, is equal to, what is it equal to again? Anyone remember? Mia? No. Anyone? Alex? Sorry. I thought you had your hand up. Do you know the rule for the binomial distribution again?
It's n choose x.
N choose x, good, stop there. So that's a hint. What's the next bit? Noah, do you remember? Yes, it is something to the power of x. He is correct. What are we missing? What is there? What goes there?
Probability?
Yeah. Probability of success. It's always what you're looking for. So that x represents how many of those do you want? So if I'm rolling a 3 and I want a 3, how many 3s do I want? And what's the chance of success? How many of those do I want? Times by, what's the next one? What's the one I'm missing?
1 minus p.
Very good.
You do 1 minus p.
1 minus p is the chance of failure. So this is the chance of success. If it's 70%, that must be 30%. And then, what's the power? Very good. N is the total number of trials minus the ones that you wanted. Then it must be the ones that you don't want. Okay, so the probability of failure, the ones that you don't want, how many of those do you want? That's the power, right? This is your rule. Now let's test your memory even further. Last session, which is the sheet that we're about to go through, I went through the median, variance, and standard deviation rule. Now we already know standard deviation is just the square root of the variance. So you just need to know what E of x is equal to for a binomial, chapter 14. And you just need to know the variance of x. What's the formula for the expected value of a binomial distribution again? What's E of x equal to? Because as I'm revising this, you're going to do the first 2 or 3 questions from that example. Okay, so you got your formula. What's E of x equals to? NP. N times P. So if you had 10 trials and flipping a coin, you know the chance of getting tails is 50%, then I expect out of the 10 times half, or 10 times 50%, 5 of them should be tails. That's my expectation. Okay, so in the long run, my mean is the number of trials times the probability of success. Now that only works specifically where I can just do 50% of 10 because it's independent, 2 outcomes, and the probability is constant for all of them. That's why this works. Okay, you naturally do that logically, but that's because back in year 7 to 10, it has been, ironically, a binomial problem. Okay, and variance. What's the variance formula again? So NP is your expected. What's the variance? These will all be in your formula sheet, but it's good to know so when you solve the problem, you remember.
NP times 1 minus P.
Good. They normally say NPQ. I don't think they write that in your exam, but if they do, the Q is the probability of failure. So P is success, Q is failure. So we then write NP times 1 minus P. Okay? Now, just to practice your skills, that's pretty much the summary of things that you needed to know from 14ABC. Okay, those are the formulas. That's what you need to know. And your CAS, that's binomial PDF. Yeah, binomial CDF is cumulative. Have a go with this question to start off with, and we'll go through the answers. But I want you to read the question, identify the probability of success, identify the number of trials, and answer up to probability is operating. Yeah. So you should be able to do with the amount of information I just gave you, you should be able to do A, I, double I, and triple I. Leave the next 2 for me to teach you. Try this one. I'm going to pause the video. I may need to check my answer on that one. I think I read the question wrong and I approached it wrong. In the meantime, just in the interest of time, I'll come back to this one. Let's do this question here. What I wanted to teach you was more about to use inverse binomial. One of the most infamous questions that's been there for ages. In your textbook, this question here, question 7. Question 7, it's possible to do, but back then I had to use an Excel spreadsheet. And then previous years they were doing trial and error. But there was a quicker way, which I only recently learned the syntax to it. Yeah, so I didn't know about that. I didn't know it existed. I just wanted to make sure you've learned how to do it too. It's a very similar problem to the one we were doing just now. So this one is saying, is practicing goaling for netball. She knows that her past experience that her chance of making any one shot is 70%. So what they're saying is probability of success is 0.7. Her coach has asked her to keep practicing until she scores 50 goals. Okay, so getting one shot in, that's 1 goal, that's 0.7. But they want to get a total of 50 goals, right? How many shots? So we don't know how many shots is needed at the moment. So how many shots is needed to attempt to ensure that the probability of scoring at least 50 goals, so it's saying at least 50, so I want at least 50 goals, okay? But I want the probability of success to be more than 99. Kind of similar to before, except this one, we actually know how many shots is actually needed. Okay, so here, you're trying to find the total number of shots, minimum number of shots, to ensure that you get 99% chance. Now, logically, if you were to do this, 50 onwards is a lot of possibilities that you can do. So we do the reverse. What you're meant to work out is then 1 minus PR x less than or equal to 49. Okay, because it's from 50 onwards. So then if you want 50 onwards, then let's work out what is not good. So if they got 49 shots in, that's not good. So 49 and less is bad. So 1 minus this probability is more calculable. But we don't want to be sitting there and doing this. So that's a problem. So this is where your CAS has to come in. Still the same thing as what I just taught you before. Same idea. Cross the ones just like we do. So minus the ones, you get 0.01. And then you divide the negative, so you get 0.01 PR x less than negative 49, right? But to do this cumulatively without knowing n is tricky. So you can either trial and error, okay, or do a spreadsheet, which is what I used to do. I had to do this whole binomial thing and do a spreadsheet and keep fill in, kind of like your Newton's method, where I had to pull it all the way down until I found the percentage that I wanted, which is 99 and above. But in this case, you can actually go to your CAS and you can go to binomial, so menu, probability, distributions, go all the way down. See, there's two here. And the two examples I want to show you were the two different ones. One's cumulative is what we're wanting, okay? And then the other one is more like within that instance for a probability of chance that you actually know that you want. So that's the one that, the next example that you're doing. So that next question that you got, that's the one we use. But then we do this one for that question 7. So binomial n, which is cumulative probability. Cumulative means moving from left to right. So you're always adding from the smallest value to the largest value. So if you think about our situation, I'm saying I want 49 and less, everything up until this point, okay? Up until this point, I want the probability to be less than 0.01. That's what I'm saying. So all of this area adding up to this point is less than 0.01. So that's cumulative, yeah? So what you do here is you say, I want 0.01, or you can say 1 minus 0.99. It's up to you if you can't be bothered working it out at the time. Type in the probability of success. In this case, it was 70% chance of being able to get it in. And number of successes, well, we know it's 49 being the cutoff. Because it's discrete, 49 is the shot, 50 is what we truly want, this is what we don't want. So 1 minus this will give us everything else we want. Okay? So from here, the calculator can do that. Now the matrix form is nice, especially when you're in an exam. Matrix form gives you in a matrix box, but it gives you one before and one after. If you do it without it, it just gives you an answer. So I prefer doing the matrix. So if you tick it off, it looks like this. And back then, oh man, it took me a while to do on a spreadsheet just to get to, you go all the way down. I see 85, and I see 86. So you can see, we said we want it to be less than, was it greater than or less than? I've forgotten now. But this is when it's going to be less than 0.01. Okay, so this is when it's still 0.01, bigger than 0.01 by a bit, and this is when it's less than. So the matrix form tells you the one before and the one after. So I can tell that the person needs to do 86 shots minimum if the probability of success is 70%, and they want to get a minimum of 50 onwards. That's 99% of the time. 99% of it is a 50 goal and above. They need to do 86 shots to get there. Okay, so that question there in the past for me was very painful to do because there are many similar ones beforehand, but you can do that without using the CAS stuff. You can actually do the log stuff and you'll be able to solve it. It's just question 7. Notoriously, at that time, we didn't have the CAS functions that we could do, but now you've got that inverse norm. That's worthwhile knowing how to do. So this skill here, they're still assessing for your exams, knowing how to do that. That's why I wanted to do today's lesson. I just wanted to make sure you've seen how to work with those kind of questions. And this one, I'm probably going to skip it for now, but you've got a bit of my own answers here. That's the actual answer, but see the difference? It's inverse binomial. Okay, this is when you actually know the probability of what you want. So you know exactly, I want this particular probability. I know n is 22. How many x greater than? So I'm essentially working out how many successes do I want. That's different. So one is working out for successes and the other one is working out for the number of trials you need. Okay, so that's that question there. I am wary of the time. We've got half an hour to go through 15A, but the skills I wanted you to get was this one. Okay, so learning, there's 2 CAS skills that you can do. And this is one of the key ones I wanted. So take a screenshot or something, or I'll take a screenshot of this just to help you answer that question if you do this in your textbook. We can always circle back to this. If you are having troubles with 14C, we can always circle back. I just need to make sure I go through each of the content. But that there is inverse binomial. I reckon that's a useful tool to have there. So just write on the side to help you remember. That's cumulative probability. Cumulative probability. That's your P for success. 49 is the X equals number of success. And the 1, if you're curious what the 1 is, it just means matrix. If you put 0 there, then it won't be a matrix form. If you put a 1, 2, 3, or whatever it is, it just means give me a matrix form. Okay, it's just a syntax thing. So that could be useful for you when you're working on questions where they ask n to be a greater than or certain amount. Okay? So cumulative from left to right, chance of success. This is the number of successes you want, so x equals 2 up until that point. And the number 1 just tells you matrix form or not. Okay, so if you didn't put it in, it would just be, for example, if I did it again, and I took off that, it would just be like that. And it's just the difference between the two. So instead of going in and doing the tick, you can type that in, and then you'll get your matrix form. Okay?